Okay, in this podcast we're going to do some pretty basic factor label, using some density problems. So let's start off by, let me get my calculator back up and tell it to always stay in front. Okay, so I want to know what's the volume of a tank that can hold so many kilograms of methanol with a density of this. Okay, so it's easiest, I think, to figure out what you're trying to find first. So what I'm trying to find is the volume. And I always ask myself, volume of what? Of a tank that holds that many kilograms. So that's my given, 18754 kilograms. Now I have a density given to me also, so I can use that as a conversion factor, either 0.788 grams over 1 centimeter cubed, or I could use it the other way if that helps me cancel units. Okay. So if I start with my given, 18754 kilograms, and I'm going to use this fence post process. It might be a little bit easier for you. And put that over 1. I don't have anything here in kilograms, so I've got to first convert kilograms to grams. And what I know is 1 kilogram, and I need the kilograms down here so this cancels, is 1,000 grams. Now that I've used that, I can take my grams from here, 0.788 grams, and that is going to be 1 centimeter cubed. And if I've done everything right, I can cancel kilograms, I cancel grams, and I should be left here with the units that I want, and I am. So if I punch that now, it's 18754 times 1,000. Divide by 0.788, and I get a huge number. Okay, so I want, let me see, I've got 5 sig figs here, so I'm going to want 5 here, 2, 3, 4, 5. So I'm going to make this 2.380 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th centimeters cubed. Okay, let's take a look at the next one. Alright, what's the density of a board whose dimensions are these, and my mass is this? So I know density is mass over volume. So, and I want the units to be grams per milliliter. So I first got to convert this mass of 28.6 kilograms to grams. I know 1 kilogram is 1,000 grams. So this is going to give me 28,600 grams. Kilograms will cancel. I'm going to multiply this out, and if I do, I'm going to get 5.554 times 10.6 times 199, and I get 11,686. 11,686, and my units would be centimeters times centimeters times centimeters, which is centimeters cubed. So I now have my mass. I put it over my volume, 11,686 milliliters. Well, centimeters cubed are the same as milliliters, so I can just make this milliliters, and I get 28600. Oops, where did my 6 go? 600 divide by, and I'm just going to go up and pick up this number by that, and I get, let me see, I've got 3 sig figs, 3 sig figs, I want 3 sig figs, 2.45, my units are grams per milliliter, grams per milliliter. Okay. Number 3, calcium chloride is used as a deicer on roads. It has a density of 2.5 grams per centimeter cubed. What is the mass of 15 liters? Okay, so I'm trying to find mass, and I ask myself, mass of what? And it's mass of 15 liters. So I'm going to start with my 15.0 liters, and I'm going to put that over 1. And I'm going to, I have to get from liters to centimeters cubed. So what I know is 1 liter is 1,000 milliliters, and I know 1 milliliter is 1 centimeter cubed. And now I can use this, and I want centimeters cubed down here so that it will cancel. So what I know is 1 centimeter cubed is 2.50 grams. Okay, if I've done everything right, liters cancel liters, milliliters cancel milliliters, centimeters cubed cancel centimeters, and I'm left with what I'm trying to solve for. So if I punch all that into my calculator, I get 15 times 1,000 times 2.5, and all divided by 1, and that will give me 37,500 grams. Okay. What is the volume of this many grams of water if the density is this? Okay, so I'm trying to find volume. Volume of what? Volume of 2120.0 grams. Okay, I'm going to start with that given, 2120.0 grams. I put that over 1. I'm going to use a fence post here. So grams, I can use this conversion, right? 1 gram, I'm sorry, 0.99987 grams is 1 centimeter cubed. So I should be done because I'm canceling grams. I've left with centimeter cubed. It did not specify what volume units to use. So all I have to do is plug it and chug it, and I get 2120 divide by 0.99987, and I get 2120 and milliliters. Okay, not real surprising because this density is almost 1, which says there's 1 gram for 1 centimeter cubed. So my volume comes out the same. Well, actually, I've got 5 sig figs here, so I can go 5, 2120.3, so it's not exactly the same. Alright, what's the volume of 2,120 grams of ice? And if the ice has a density here. So I'm trying to find volume. I am given 2,120 grams of ice. Okay? This is a little bit different from the last problem. So my given is 2120.0 grams. I'm going to put that over 1. And what I know is there's 0.9310 grams in 1 centimeter cubed. And all I'm looking for is volume. Doesn't specify the unit, so I'm just going to plug this, and I get 2120 divide by 0.931, and I get, no, I've got 5 sig figs, so I can have 5. I get 2277.1 centimeters cubed of ice. Alright, let's do one more. Alright, a student fills a graduated cylinder with water and reads the meniscus at 25.8 milliliters. Okay? Student then dropped the solid material in the graduated cylinder, and the water rose and it went up to 35.9 milliliters. If the density is 2.99 grams per milliliter, determine the mass. So I'm trying to find mass, and mass of what? Well, the mass of an object whose volume rose this much. So I'm going to get the object's volume by subtracting how much it rose. So that's my given, 10.1 liters. So 10.1 liters, and I have a density here, but it's in grams per milliliter, so I got to convert that. And I can use a fence post or use factors here. I'll just use factors here. 1 liter is 1,000 milliliters, and what I know is 1 milliliter is 2.99 grams. If I multiply that out, I get 10.1 times 1,000 times, can't read my own writing, 2.99, and I get 30,199. So let me see, I got 3 sig figs, 3 sig figs, so I want 3 sig figs, so it's 30200 grams. I want to make sure my units are canceled, right? So I'm good. Okay, we're going to stop there.